Hello, my name is Tomer Saban. I'm a software developer at Red Hat, and today I'm going to do a deep dive about affinity enforcement. So let's start. So we are going to start with the motivation behind affinity, and from there we are going to proceed to the background section. So in the background part, I'm going to explain what are affinity rules, and I'm also going to explain a little bit about scheduling and how affinity rules and scheduling are connected. I'm going to explain the challenges in affinity rules enforcement there, and you're going to understand what's the problem here, which is where there are some cases where affinity rules are not enforced yet in its system. So we are going to talk about it in the background part. Then we are going to move to the what's new part, and in that part I'm going to explain how we address the problems you saw in the background part. So we're going to do it using the new feature, the Affinity Rules Enforcement Manager, and we also have the new contradiction check, which is using a new algorithm called the Unified Affinity Group algorithm, and I'm going to get into that later also. After that, I'm going to move to the future plans, and in the future plans section I'm going to explain what are we planning for this feature. So about the motivation behind Affinity. Affinity is basically a group of VMs that you specify, that the admin specified that they should run on the same hypervisor or on separate hypervisor in the case of negative affinity. A common case for where you would want to use affinity is for distributed database, where if you get a distributed database that runs on several VMs, you would like them to, they will communicate a lot with each other. So you would like to put them on the same hypervisor, so they communicate on the hypervisor instead of using your network. And in order to avoid the user mistakes, we're going to use the improved feature that we added in this version, which helps us detect contradictions in the affinity rules, which we couldn't do before. It's going to be using the Unified Affinity Groups algorithm that we are going to see later in the can-do action of the affinity groups. Also, the new feature, the Affinity Rules Enforcement Manager, is going to help us with the automatic affinity enforcement. You're going to see that using this feature we can achieve automatic enforcement for VMs which are already running, and we're going to do it without the data center admin intervention. So we are going to get to that later. So in this part of the presentation, I'm going to give you a little background about the problem we're trying to solve. So I'm going to talk about the scheduler and scheduling policies, and after that I'm going to explain to you about affinity groups and how to recognize when affinity groups are enforced and when they are not. And then you're going to understand exactly what's the problem we're trying to solve here. So let's start. So what is the scheduler? First of all, the scheduler is a logical unit responsible for scheduling, which means basically you get VMs, and the VM run on a hypervisor or host if you like, and you use the scheduler when you want to decide where to migrate the VM. If I'm saying that I want to migrate a VM from one host, then the scheduler decides based on the scheduling policies where to migrate it. So scheduling policies is basically a group of policy units which which the admin can specify. And the policy units, they are divided into several groups I'm going to show you later. And they're divided into filters and weights, which I'm also going to explain to you later. So when the scheduler is used, first of all for migration, as I said earlier, and also when you power up a VM, the scheduler decides where to run the VM on. So this shows how the scheduler works. Basically, you got here the host on the left, and you get a VM that you want to migrate it. So you ask the scheduler, what should I migrate the VM to? So the scheduler uses the scheduling policy, which consists of all these policies here. So you can see you got the Affinity Rules policy, which I'm going to explain later. You got CPU policy, which is basically a policy that filters hosts based on their CPU. For example, if you got a VM that has two virtual CPUs, then you have to use a host that also has at least two CPUs. So that's what this policy does. The same thing goes for RAM. When you run a VM, you want to make sure that the host you migrated to has enough RAM to run the VM. And you got also the even distribution, which tries to make sure that no host has is loaded more than the other one. So you distribute the VMs accordingly. So in that case, we ask the scheduler where to migrate the VM, and the scheduler tells us migrate the VM to this host down here, and that's it. Now scheduling policies is basically, you can see them in the new scheduling policy dialog, and it consists of filters and weights. Filters, basically it's a function that gets a list of hosts, of possible hosts, and it filters them based on the policies here. What I need to do is to drag policies from here to this place here, and then that's how we set the scheduling policy. The weights are a function that receive a list of hosts, and instead of filtering them, it gives each host a score, such that the lowest score is considered more likely, a host that is more likely to be chosen. So now we are going to talk about affinity groups. As I mentioned before, affinity groups are divided into two groups, which are the positive affinity groups and the negative ones. So here you can see I marked the positive ones in green and the negative groups in red. So for example, here is broken affinity rules. You can see here you got affinity group 1, which has these two VMs and this one here. And because they are divided between the hosts A and B, this affinity group is broken. The same goes for these two, affinity group 2. We got one VM on host A and one VM on host B. Of course, they can also, if this VM, for example, was on host C, it was also broken. That's obvious. And here you got 3 VMs in a negative affinity group, which belong to affinity group number 3. So as you can see, they are on the same host, and because of that, that affinity group is also broken. So if I would enforce these affinity groups, then what I would get would be something like this. You see that affinity group 1, all the VMs are on host A, and affinity group 2, all the VMs are on host B, and affinity group 3, which is the negative one, each VM is on a separate host. We don't see 2 VMs from this negative affinity group which are on the same host. So all these affinity groups are enforced. So now I'm going to talk about what's new. So we basically got we got one new feature and one improvement we did to the can-do action. And now for those of you who doesn't know what can-do action is, basically each time you do some kind of operation in engine, for example, adding affinity groups, editing affinity groups, before engine runs the command, before engine runs the action, it runs the can-do action, which basically checks if you're allowed to do the action, if you can do it logically, and that's what we have. So for the command of add affinity group or edit affinity group, we improved the way it checks for contradictions. I'm going to explain on the next slide how exactly we did it. And the other thing is a feature called Affinity Rules Enforcement Manager, or AREM for short. So from now I'm going to refer to it as AREM. So pay attention, please. So how contradiction checks work. So here we have two affinity groups. One is positive and one is negative. So we are checking this affinity groups for contradictions using the old algorithm. So here you can see you got VMA, VMB, and VMC. This and this is the same VM. The same goes for this too. So these two affinity groups, their intersection is going to be B and C. So basically that's the contradiction. You can't have B and C on the same host and in the same time have them on the different hosts. So that's the contradiction here. So what the old algorithm did basically is it checked for every positive affinity group G1 and for every negative affinity group G2. If their intersection is more than one VM, then it says found contradiction. Else, if all these affinity groups are not contradicting each other, then it's going to return true, which means that you can do the action, can run the action. So what happens when we check these affinity groups using the old algorithm? So you got two positive affinity groups. One of them consists of VMs A and B. The other one is B and C. And we got a negative group of A and C. So using the old algorithm, if you check it by yourself, you'll see that it's going to return true because there is no intersection of more than one of a positive affinity group and a negative affinity group. But the difference here is that these two positive affinity groups divide this one into two different groups. So this one and the intersection of this one and the negative affinity group is none. So it's valid according to the old algorithm. Same goes for this one, but if you merge these two groups together, you get A, B, and C. And as we saw here, these two VMs, B and C, actually do contradict each other. The affinity groups contradict each other, and the cause of that is B and C here. So the old algorithm would say no contradiction found, although as I showed to you, there is a contradiction here. So how did we solve this? We changed the can-do action to use something we call unified affinity group algorithm. How it works? First of all, for each VM, it puts it on a different group, and then it starts merging those groups based on the affinity group. So, for example, here you got positive affinity group 1, which contains A and B, and another affinity group which contains B and C. So the algorithm started merging them. First of all, by the first rule, so you got A and B on one group and C by itself. Then when you apply the second rule, you get A, B, and C on the same affinity group. So in this case, there is no contradiction. It's okay, and it also makes sense because there is no negative affinity groups here, so there is no possible contradiction. In this example from the other end, it's the same as we saw in the earlier slide. We start merging these groups. We get the group A, B, and C, and here we added a negative affinity group which consists of A and C. So what happens when you start applying the rules, you get to this rule, and then you see the intersection of AC and ABC is more than one VM. It's A and C. So in this case, the unified affinity group algorithm found the contradiction. So that's how we do it. So now I'm going to talk about the Affinity Rules Enforcement Manager, which is a new feature which helps enforce affinity rules for VMs which are already running. Before we had AREM, we wouldn't be forcing affinity rules which are already running. So this feature basically tries to do it on the fly. So how it does it? First of all, that's basically the way it works. It runs in the background, and each interval of 5 minutes, it tries to check for contradictions using the UAG algorithm I showed you in the previous slide. If it doesn't find any contradiction, then it waits for the next interval. And if it does find a contradiction, it chooses a problematic VM from the affinity groups which it found. And I'm going to explain later exactly how it does it. And then it chooses a candidate host and migrates the VM to it if it's possible. And I'm going also to explain later how do we choose the host. And the important thing to explain is this is a manager that runs in the background, and it does one migration at a time. And the reason it does it because we don't want to put too much load on the network. So we allow only one migration at a time. So for example, if AREM interval reached and it sees that a migration is already done in the system, then it won't do any migration even if there is another contradiction. Once it sees that there is a migration that is currently occurring in the system, it waits for the next interval to enforce the affinity rules. So now I'm going to explain to you how the unified affinity groups algorithm helps us to find the next VM to migrate. So what we do, we use the unified affinity groups algorithm. As you can see here, you got 3 positive affinity groups. You got one consists of A and B, another one with B and C, and another one with D and E. And we also got a negative group which consists of A and D. So in this case, there are no contradictions. These 2 groups became unified affinity group. This is unified affinity group. So these 2 groups became A, B, and C, which is one unified affinity group. This one stayed the same, and the negative affinity group also stays the same after after applying the UAG algorithm. So what's important to notice here is that no VM belongs to more than one positive group after applying the UAG algorithm. You can see A is only here, B is only here, E is only in this UAG, and those it's okay because they are in the negative group. So it's fine to have them both here and here, for example. And another thing is that we know there is no affinity rule contradictions, which makes our life simpler when we want to enforce the affinity rules. Now we decided that AREM should enforce the affinity groups in a specific order. So in order to do that, we had to make sure that as long as he didn't finish to enforce a specific affinity group, he has to choose the same group each time between intervals. So now I'm going to explain to you how we did it on the next slide. So after we apply the unified affinity groups algorithm, we need to decide which affinity group we are going to enforce first. So in this case, we start sorting the affinity groups. So if you look here at the upper side of the slide, you can see we have three UAGs. One contains 6 VMs, one 4 VMs, and one contains only 2 VMs. So in this case, the algorithm sees that the largest size of UAG is 6, which is UAG A. So therefore, it chooses UAG A. But what happens is we have more than one affinity group which with the same size. So in that case, you can see here we have UAG A, B, and C. All of them have 4 VMs, which means that the largest size is 4. And I marked here the IDs of the VMs. Each VM gets a unique ID in the system. So if you can see, we got 6, 4, 3, and 2. And this one is marked because it's the lowest ID, the lowest VM ID in this group. So I did the same things for this one and this one. And we just sort them by the lowest ID. The reason we do that is because when we are not using the affinity group ID, for example, because when we do the UAG, we don't have a unique ID for the affinity group because we combined a few affinity groups together. So that's why we use the lowest ID. So in this case, you get 2, 1, and 9. And the lowest ID from all of these groups is 1. So in this case, it's going to enforce UAG B before A and C, and after that UAG A, and then at the end UAG C. See? 1, 2, 9. So after we choose which affinity group we want to enforce, now we have to choose which VM and where we're going to migrate it in order to enforce the affinity group. Now, affinity groups can't usually won't be enforced in one migration. So, in this case, we're going to choose one VM that is going to bring us closer into enforcing the affinity group. So here we're getting to a little problem because choosing which VM to migrate and where to migrate it to enforce the affinity group, it's a dependency problem with conflicts. Conflicts because of the negative affinity groups. For that reason, we know that there is no algorithm that solves it in a reasonable time, basically. Or if you want the official term, it means that this problem can be reduced to a dependency problem with conflicts, and for that reason, it's an NP-complete problem. That's the computer science theory term for it. So we can't find the optimal solution. We can't find the optimal solution in a reasonable time. So for that reason, we had to do a small workaround in order for it to work. So it's going to solve the problem in most cases, but it's not good. But there are some cases theoretically that it won't be solved. So how we solved it in the end? So what we did is we want to migrate VMs from the host with the least number of VMs from the specific affinity group, and we want to migrate it to the host with most number of VMs from that affinity group. I'm also talking about positive affinity groups right now. So here in the bottom side of the screen you can see a small example. Here in blue you got one affinity group, the yellow is also, it's another affinity group, and you got the light blue affinity group. So let's say we decided that we want to enforce the blue affinity group first. So in that case, the host that has the most most VMs from the blue affinity group is the host right here on the left, which has 5 VMs. And the host with the least number of VMs from this blue affinity group is the host on the right, which has only 2 VMs. So what our algorithm is basically doing is it's choosing a VM from the host with this from this host, and it preferably want to migrate it to this host. So once we chose the VM we want to migrate, we ask the scheduler can schedule, which is a method that basically checks if a VM can be migrated, if the migration we want can be scheduled. And if it can, then we migrate the VM, and if it doesn't and there is no other VM from that host that can be migrated, we also check it using can schedule. In that case, we proceed to enforce the next affinity group, so we won't waste the interval we got. So that's the way we chose VM, and we chose where to migrate it. So I want to show you a demonstration of AREM in action, but before I do that, I'm going to talk about how do you enable disable AREM and how you know if it works. So first of all, you got a tool called engine config in oVirt engine, and if you want to enable AREM, you do this. You do engine config -s Affinity Rules Enforcement Manager enabled equals true, and if you want to disable it, you do the same with false in the end. And if you want to check if it's enabled or not, then you do the -g. So that's the difference. One more thing is you can see in the log, you can also see if you want to see if AREM is working, you can see in the logs. You can see in var log oVirt engine log. You can see you will see a message like this: Affinity Rules Enforcement Manager started. And each time it finds a VM that violates the affinity groups, then it's going to print something like this to the log: positive affinity group violation detected for VM. This is the VM ID. This of course means that a positive affinity group violation found, and the same goes for a negative affinity group violation. So now I'm going to show you the Affinity Rules Enforcement Manager in action. So what we can see here is that we have 2 hosts. One is called T1 and one is called T23, and we got 3 affinity groups. 2 of them are positive. Affinity group 1 is Affinity group A consists of VM A1 and A2. Affinity group B is consisting of B1 and B2, and affinity group C is a negative 1, which consists of negative 1 and negative 2. And you can see here A1, B2, negative 2, and negative 1 are on host T1, and on host T23 we get A2 and B1. So the positive affinity group A is broken because we got one VM here, one VM here, and one VM here, and this is a positive affinity group. The same goes for B, and we got 2 VMs in a negative affinity group, which are running on the same host. So now we're going to see how AREM enforces those VMs. One thing I want to mention in this version of oVirt, what I did is I changed the intervals to be 20 seconds, so that you can see how AREM enforces the affinity rules. But on your version of oVirt, it's going to be an interval of 5 minutes, so it's going to be slower. So let's see how it works. One thing I want to mention is AREM only enforces affinity groups which are in enforcing hard, which means they are enforcing. Soft affinity we are not enforcing. So what I did is I changed here to soft affinity I changed all the affinity groups of enforcing status to hard, because before that they were soft. So I can put the VMs wherever I want. Once I did change the enforcing to hard, AREM started enforcing them. You're going to see in a second. Here you see that the negative affinity groups is already enforced. The same goes for affinity group A, which was just enforced right now. In a few seconds you're going to see that affinity group B, one of them is going to migrate to another host. So here you can see B1 is migrating to T1, and this is what we got in the end. So now all the affinity groups are enforced. So what we can see here is on host T1 we got affinity group, all the VMs from affinity group A, A1 and A2 are on host T1. Same goes for B1 and B2, and the VMs from the negative affinity groups, each one is on different hosts. And one is on T1, the other one is on T23. So all the affinity groups are enforced, and that's what we wanted to get. So about future plans, this is what we have in mind. We want to make a visual presentation of affinity groups in such a way, using the unified affinity groups algorithm, we can suggest ways to optimize the affinity groups. So that's one thing we had in mind. Also, right now the scheduler decides where to migrate a VM based on the VM spec, but only for the current VM. If we have a positive affinity groups, for positive affinity group, then we want to filter hosts from advanced that can't run all the VMs in the affinity group. So that's one thing. That's also something we want to do. And the third thing is we want to change the affinity policy in the scheduler such that the host with the highest number of VMs will be chosen. So this also going to happen soon. If we have that, then the scheduler and AREM are going to work together. The scheduler is going to help AREM to enforce the affinity groups faster. So that's what we are planning for the future. So for summary, the affinity rules contradictions are now prevented before they are created. So for summary, as I showed you in the presentation, we can find the contradictions we couldn't do before using the UAG algorithm. So this helps us to prevent affinity rules contradictions before they are created. The second thing is using the Affinity Rules Enforcement Manager. The affinity rules are now being enforced automatically for all VMs, which means also for running VMs. So that's the second thing. If you want to see some more information about it, you can see our oVirt wiki. So you can see here the affinity. You can get here information about the Affinity Rules Enforcement Manager, or the scheduler, also migration, and the VM affinity groups. So that's it. Thank you very much.